A horizontal tangent occurs when our derivative is 0. So let's go ahead and look at the derivative dy dx. That is, for polar curves, dr d theta, sine of theta, plus r cosine of theta, over dr d theta cosine of theta minus r sine of theta. So dr d theta, let's go ahead and find that real quick. Dr d theta is simply the derivative of this. That's cosine of theta. So our derivative then is cosine times sine. So sine theta cosine theta plus r, which is 3 plus sine theta times cosine theta, over, and then cosine squared theta minus r times sine. So we want this to equal 0 because we want a horizontal tangent. So that's this numerator equal to 0. Let's look at that. We've got sine theta cosine theta. We've got plus another sine theta cosine theta, and then plus 3 cosine theta. Let's factor out cosine of theta. We get 2 sine of theta plus 3 times cosine theta. We want that to equal 0. So, of course, that's any time that theta is pi over 2 plus some multiple of pi for this cosine, or when sine of theta is negative 3/2. Of course, that never happens, and so since that never happens, these are going to be our only places. Let's double check to make sure our denominator is not 0 as well, because that would complicate some things. So if we look at, well, this would be pi over 2 plus k pi. If we plug that in here into the denominator, well, cosine squared of all of those is going to be 0, of course. And then over here, we're going to have, well, sine is either going to be plus or minus 1 at those places. And, of course, 3 plus that times, so 3 plus or minus 1 times plus or minus 1 will never be 0. And so we're good. So those are the values of theta. If we want to know r, of course, it's going to be, so this is our theta. R is 3 plus the sine of that. So 3, of course, plus or minus 1. And, of course, it depends on k. If k is an even number, it's plus 1. And it's if it's odd, it's minus 1. So we could write that as plus negative 1 to the k. Well, that's not really necessary. I think if you just said this, everyone would know what you're talking about.